Alright, so here comes another chapter, vectors geometry. So this unit is quite different from the previous unit in terms that you're not talking about complex number anymore. But what we'll be doing, it will be quite similar to physics, where we are going to split any line on a graph into the x component and the y component, and then we're going to do some math using those numbers. So first of all, here comes the introduction to vectors. A vector is a line defined by both its direction and magnitude, which is pretty much the same as physics, where direction as in like the angles that the lines is going in, and the magnitude would just be the length of the line. From an initial point A to a terminal point B. So from one point to another on a graph, from A to B, whether you have a line that goes here or x and y axis like this. Let's say I have a line going from A to B. Then this line going from A to B in this particular direction can then be expressed using vector AB. So we use this little arrow up at the top above the AB to indicate vector. And the length of this line, similar to modulus, we use this symbol to describe the length of your vector. Regardless of the location, any two vectors with equal length and same magnitude are considered to be equal. So using the example that I just drew, I can come up with another random vector. Let's say I have a point here. Oops. I have a point here, and this line has exactly the same length as the one that I drew with the same directions, and here I can then consider this line as the same vector as the one that we drew. So it doesn't matter where you start your vector, at which point you start to draw your line. If they go in the same direction, as in like parallel, and they have the same length on the line, then they are considered to be the same. When we are to add vectors together, doing arithmetic with these vectors, the concept is, well, once again, exactly the same as in physics. So for those of you who don't have physics in your certificate, what happens is we're going to consider these vectors as basically lines. And if you want to add two vectors together, you are going to basically recreate the vector here. And then if I have a vector B, then the sum of vector A and vector B will just be something like this. I can basically draw the vectors or the arrows from tail to the head, and then head touch the tail, you start your vector again, and that means overall the vector that we drew here, the two of them, as you add them together, we will end up with a resultant vector, the line that goes from here to there. Now some of you may wonder, what happened if I reverse the order of the two terms? So let's say, instead of having the blue line first, let me start with the red line here. Let me put these two vectors back to my picture. So what happens if I have B plus A? Now, if I'm to start with vector B first, and then add it by vector A, I will still end up with a resultant vector that goes in the same direction as this one, with the same magnitude. So it doesn't matter if you decide to add the vectors in different order. So you understand how to add the vectors together. And when it comes to a multiplication, like 3 times vector b, that's basically the same as in using vector b once, and then you're going to use it again. So let me copy this vector again, and I'm going to create a new vector here with exactly the same direction, going in the same direction with the same length, and then I go for one more time, and that will give us the vector from start to finish that is 3 times the vector b. Adding and subtracting vectors are pretty much the same concept, but there is one important difference between plus and minus. If you were to subtract a vector, the idea is the same as adding its opposite. So what does it mean by an opposite vector? You're basically using the same line with your vector going in the opposite direction. So if I have vector A here, this vector, bring it over, and I only want half of this, 0.5 times vector A. So while keeping the direction the same, I'm going to make it half as long. And then with vector B, this time, since we are having a negative vector, I will have the vector going from its bottom back to the left upper corner. So now bringing this to the other side, this time I will see a vector starting from here to there for vector A, and then for vector B, because it is negative vector, I go opposite, therefore giving us the final result, or the resultant vector going in this direction.